So today we are starting our first day of the unit for Unit 4, which is bonding. We're going to be talking about ionic and covalent bonds today, and then how to draw what's called Lewis dot structures of those. So, first thing we need to know, though, is what is a bond? What is a chemical bond? So, atoms are going to bond together in order to satisfy what we call the octet rule. And this octet rule just means that atoms are going to be most stable when they have 8 valence electrons. Okay, so last unit, we should have kind of been able to use the periodic table to figure out how many valence electrons an atom has based on what group it's in. Okay, we're going to review that down here, but this is just a good way to view that. So sodium is in group 1. It only has 1 valence electron. We just draw 1 dot for it, right? So it's unstable. It really wants to get rid of that 1 electron. So it's going to do something to get rid of it. Chlorine, however, has 7. It really wants to get to 8, so it's going to try and gain 1 so that it's happy and satisfied at 8. Neon is in group 18. It already has 8 valence electrons, so it's stable. It's not going to do anything. It's just going to stay and keep its 8 valence. Okay? All right, so we're going to go through here, and we are going to label what the valence electrons are, and the charge would be based on what group our element is in. So we're going to start with valence electrons. So valence electrons, it's based on the group number. So this is group 1. They have 1 valence electron. Group 2, what do you think they're going to have? 2. We're going to skip this entire middle section, our transition metals, where that D block is. We're going to skip it because these guys are a little wonky with their valence electrons, so we're not going to worry about these guys. We won't ask you anything about these guys for their valence electrons. Okay? Next, we hit group 13. How many do you think group 13 is going to have? 3. Yeah. So if group 18 has 8, right, group 13 would have 3. What about group 14 here? 4. Next one? 5, 6, 7, 8. Good. So based on what group it's in, that determines how many valence electrons there are. And if you forget that, your periodic table also kind of tells you that. So you see wherever it says the A, like 1A, 2A, 3A, 4A, that A number is going to tell you how many valence electrons that group has. So group 13, it's 3A, so everything in group 13 has 3 valence electrons. All right, so now the octet rule tells us that they want to have 8. Now, we can get to 8 in one of 2 ways. Either our elements can lose an electron, the valence shell that they're currently at goes down to 0, and then the energy level right below it becomes their new valence, and that's already at 8. Or they can gain electrons to get up to 8 at their current energy level. So what's going to happen is if our electrons, or if our atoms have less than 4 valence electrons, they're going to want to lose to get down to 0. Because it's going to be easier to lose 1, 2, 3 than it is going to be to have to gain 7, 6, 5 to get up to 8. However, if they're above 4, so 5, 6, 7, it's going to be easier for them to gain electrons to get to 8 than it is to lose to get down to 0. Okay? So, our charge, if we have group 1, so group 1 has 1 valence electron, do you think it's going to want to lose or gain? Lose. So if we lose electrons, what does that charge look like again? Positive or negative? Positive. Because what's the charge of an electron? Negative. So if we're losing a negative, it becomes more positive. So everything in group 1 is going to have a +1 charge. Okay. Group 2, they've got 2 valence electrons. What do you think their charge is going to be? +2, yeah. So +2, they're going to lose their 2 instead of trying to gain 6. We're going to skip over our transition metals. Group 13, they've got 3 valence electrons. What do you think they're going to do? Lose or gain? Lose, so their charge becomes +3. Good, positive. Okay. 4 is when we get a little tricky. So, what's going to happen is you're going to notice that as we increase these guys, all of the guys over here pretty much are nonmetals. Nonmetals are going to gain, metals are going to lose, okay? However, this here, we've kind of got a mixture of metals and nonmetals. We're just going to say a +or -4, and it's just going to kind of depend on the atom. And you're not really going to have to worry about that. You're not really going to have to determine, okay, is it going to be +4 or -4? You're just going to have 4 electrons, and then most of the time it's going to be minus. Okay? 5. Group 15, they've got 5 valence electrons. Do you think they're going to lose or gain? They're going to gain, and they want to gain to get to what? 8. So they're going to gain how many? 3. So the charge is going to be -3. Okay, group 16, what do you think that charge is going to be? -2. Group 17, -1. Then what about group 18? Yeah, it's just not going to have a charge, because they're already at 8, which is what they're all trying to get to. So group 18 will not have a charge. Questions? We good so far on that? Okay, so let's talk about the different types of bonds. So we have 2 types of bonds that we're going to talk about: ionic and covalent. Ionic bonds are when electrons are transferred from one atom to another. So that just means one atom is going to want to lose electrons, another atom is going to want to gain. So our atom that wants to lose is going to give away the electrons that it wants to lose to the atom or atoms that want to get more. So we're seeing a transfer or exchange of electrons, giving away, donating, and receiving. Covalent bonds, however, are when our atoms share electrons. So no one's going to be giving away or getting any more. We don't see a transfer. They're going to be sharing. They're going to say, okay, I've got this many, I've got this many. If we put them together, well, and we share, we can each have 8. Yes? Okay. So, how do you know if you have an ionic or a covalent? So ionic bonds happen when you have a metal and a non-metal. Okay? Because metals, most of our metals are on the left side of our periodic table, right? Over here. And what did we say that our charge is for these guys? So positive, negative, positive. And positive means they're going to lose. So if we have a metal in our compound, that means that we have an ionic bond, because that metal is going to give away its electrons. And then the non-metal that it's paired with is going to receive them. Okay? Now you can have a metal and a non-metal, or you can have a metal and what's called a polyatomic ion. That sounds really big and fancy, what it just means is it's already a compound. So on the back of your periodic tables, you've got this list. So on the front, you've got your periodic table, just like normal. On the back, you have this list of polyatomic ions. All of these guys are ions, and they have charges. If you have a polyion, you're going to have an ionic bond. Yes? So if you have an ion and or a metal, you have an ionic bond. That's how you're going to know. Now, whenever our metal gives away electrons, it's called a cation. Whenever our nonmetals, or our polyions, have a negative charge, they're gaining electrons, and they're called anions. Okay? Now, there is a little trick that I like to use to talk about the difference, although actually, you know what, we're going to do that on the next page, on a page in a second. So ionic bonds, you have an ionic bond if you've got a metal and or a polyion. Okay, covalent bonds are when you only have nonmetals. You have two nonmetals. That's your covalent. Okay, so let's talk about we're going to fill out this little T-chart, and we're going to talk about the differences between them, okay? So, whenever you have an ionic bond, what did I say you're going to have in order for it to be ionic? How are you going to identify it? You're going to have, what type of elements are ions? Metals. So, you're going to have a metal. Anything else? Is there anything else that I said that's going to tip you off that you've got an ionic bond? Metal and, what was that thing I just showed you on your periodic table? Not nonmetals. Polyatomic ions. So, for an ionic bond, you're going to have a metal and or a polyatomic ion present. So if you have either or both of these, it's an ionic bond. Covalent. How are you going to identify if it's covalent? Okay, what types of elements have that negative charge? Nonmetals, yeah. So we're going to have only nonmetals present. Oh, if I can. Only nonmetals present. You will not have a polyion. You will not have a metal. Okay. So, in an ionic bond, what's happening with our electrons? Yeah, we're giving, so our metals are giving them, our nonmetals or our polyions are receiving them. So we see an exchange of electrons. So it's exchanges, electrons, which means that we have atoms losing or gaining those electrons. Okay. If we have a covalent bond, what's happening with those electrons? Yeah, they're sharing them. So they share electrons. And this is because of that octet rule. Because they're going to share in order to have 8. Okay. Is there anything else that you want to add to this chart? Anything that you think is of note of your differences? Huh? Okay. All right. Yeah, that's pretty much all I wanted to add, but I wanted to give y'all a chance. If there was something that you thought would be helpful to add, then we could put that. All right. So are we okay on the difference between ionic and covalent? Yes? No? Give me thumbs. Yes, I'm good. Not really. Thumbs down for I have no clue what's going on. Okay, cool. All right. So now let's talk about how to draw these things called Lewis dot structures. Okay, now, the first thing we're going to do before we draw Lewis dot structures is determine how many valence electrons an element has and what its charge might be. So, here we have oxygen. Oxygen, I want to know what its charge would be. So what group is oxygen in? Oxygen is in group 16. So what is its charge going to be? Minus what? 2. It has 6 valence electrons. So it's going to want to gain 2 to get to 8. Okay, now I want to know how many valence electrons does sulfur have? What group is sulfur in? It's in group 16, so it has how many valence electrons? 6. So this column is asking you to identify the charge for these guys. This column is asking you to identify the valence electrons for these guys. Okay, so I'm going to give y'all a couple of minutes. I want y'all to work with your tables. Go through, fill out this chart. Those of y'all who are watching the video, pause it, fill out the chart, and then come back for the key. All right, so these are the answers. So double check that you got all of them right. For carbon, carbon is really going to be -4, but plus or minus 4 is totally appropriate, okay? If you put either, like, there's not really going to be an issue, all right? And then your valence electrons match up with what group it is. Okay. Any questions on any of this table? All right. So now let's get into ionic bonding and kind of what that really means. So, ionic bonding, you're going to have one metal and a nonmetal, or you've got a metal and a polyion in a bond. And if you have so if you've got either metal or polyion, it's ionic. What do ionic bonds do so that they satisfy the octet rule? What are they doing with their electrons? Yeah, they're giving and donating. We're transferring. So ionic bonds transfer electrons so that both elements can satisfy the octet rule. Sodium here has 1 valence electron. Chlorine has 7. So in order for sodium to be satisfied and chlorine to be satisfied, sodium can give away its 1, so that now it's down to 0. Chlorine now has 8, and they're both happy. Because whenever sodium gets down to 0, that's just the current energy level. The energy level below it is already full. Right? Because if you remember, whenever we drew all of our Bohr diagrams, right, we drew the electrons on those rings. If we got rid of whatever was in the outermost ring, our valence electrons, we still had a ring below that was full. So those 8 in the energy level below are now satisfying the octet. We just got rid of the extra ones on the outside. Whereas here, it had 7 on the outermost. So if we just add 1 to that, then it's going to have 8. Okay. So in order to draw the Lewis dot structures for the ionic compounds, we first need to know how to do it for atoms and ions. So what we're going to do is you are going to determine the number of your valence electrons, and that's how many dots you're going to draw. You're going to write the symbol of your element, and then just like kind of Hund's rule last time where you put one arrow in each box before you double, you're going to put one dot on each side before you double. So let's look at lithium. How many valence electrons does lithium have? 1. Okay, what is the symbol for lithium? Li. Okay, so how many dots are we going to place around Li? 1. So I typically start up at the top and then go clockwise, okay? However, technically you can start on any of the sides as long as once you start you're going clockwise and then you don't double up until all sides have 1. Okay? Let's talk about phosphorus. How many valence electrons does phosphorus have? 5. What's the symbol for phosphorus? P. So how many dots are we going to place around P? 5. So we're going to do 1 on each side. So top, bottom, and each side. That makes 4. And so then we can go and double up one of them to get 5. Okay, so I'm going to give y'all a few minutes. Go and do these next two. So I'm going to give y'all like 2-ish minutes to go through and do these next two. If you're watching the video, pause it, and then come back and check your work. All right, so here are the answers for boron and iodine. Now, I'm going to say whenever we start doubling up our dots, we're going to kind of treat it as if we're drawing a box around our elements, and we're going to put those dots on the lines. So we would have this, they would kind of follow the line. So we don't want to do like this. Does that make sense? We kind of want them going around the eye, following like the lines if we drew a box around it. Okay? Oxygen, symbol for oxygen is O. How many dots? 6. So, how would we do that? Good. So we'd have 2 sides that have 2, 2 sides that have 1. Okay, and then xenon. What's the symbol for xenon? Xe. How many dots? 8. So that means every side is going to have 2. Okay, questions? All right, so we're going to talk about drawing Lewis. So we know how to draw them for atoms now, but let's talk about drawing them for compounds. So what we're going to do is we're going to draw the Lewis dot structure for both elements. That's going to be step 1. Step 2 is we're going to give away the metals electrons to the non-metal. And we're going to use arrows to show that we're giving them away. Because we talked about how our metals, all of our metals, they have that positive charge. So they're going to be the ones that are donating, giving away the electrons. And the non-metals have the negative charge, so they're the ones like taking them. Okay? So we'll draw a Lewis dot structure for each one, give away what we can, and then if we need to, we'll add more atoms to make sure that everyone is satisfied, and then we're going to make it look all nice and pretty by using brackets and charges. And whenever we go through these, you'll see what that looks like. But first, we need to know what the cation and what the anion is. So the cation, that's your positive ion. And that's going to be your metal. So your metal is going to become the cation. So if the cation is the positive ion, what do you think the anion is? Yeah, it's the negative ion. And so what's gonna become the anion? The nonmetal. Good. Now, you need to remember that cation is positive and anion is negative. Two different ways that you can use to remember that. Okay? So you can choose whichever one vibes with you. Okay? First one is just kind of simple. If we write out cation, this T here looks like a plus sign. So that's the positive one. Yeah. Okay, so that's an easy way to remember cation. The T looks like a plus, so it's positive. Anion, the N, that's negative. So it's the negative one. Okay? So that's the easy, kind of boring way, in my opinion. The other way is my personal favorite. Okay? And there's a little saying that goes with it. It's cations are positively perfect. So cations are pos. Cats have pos. So they're positively perfect. They're the positive ones. And I like to draw a little cat that goes along with it. So cations are positively perfect. They're the positive ones. Okay? Now, anion, it's really similar to the word onion. Onions make you cry. So they're negative. They're bad. And then I'll draw my little onion. Okay? So, whichever way works for you, but you need to remember that your cations are your positive, your anions are your negative. Whether you know that a T looks like a plus, so that's your positive, or cats have paws, so they're positive. Cations are the positive. All right. All right, so now let's go through and start drawing the LDS for these compounds. Okay, I'm going to be using 3 different colors. You by no means have to. I just like to use them so that we can see where things are coming from. So, first thing that we're going to do is we're going to draw the Lewis dot structure for both elements. So, our elements here are Na and Cl. So Na, what is the Lewis dot structure for Na going to look like? How many dots? 1. Good. Then we're going to do the same thing for Cl. How many dots is Cl going to have? 7. All right. Okay. Now, what did step 2 say? Give the electrons from the metal to the nonmetal, and we're going to use arrows. So we're going to draw an arrow from the dot from sodium to where the missing dot for chlorine is. So missing as in where it would need to gain 1 for it to be 8. Okay, so now what we're going to do is we're going to check. All right, sodium, it wanted to lose an electron. Does it now have 0? Well, it has a positive 1 charge. After we've given away that 1 dot, how many dots would it have around it? 0. So sodium is good. Chlorine. It had 7. How many did it want? Yeah, it wants 8, so it wanted to gain 1. After it got it from the sodium, is it happy? Yes. So that just means that we need 1 of each. Okay? And now we're going to, this, however, is not your final answer. Whenever you do your assessment, you're going to have one box where you're going to show me all of this. And then you're going to have another box that says like final answer or Lewis dot structure of the compound. And that is going to be this. So we're going to draw sodium as an ion. So we said sodium would have how many dots now? 0. So we're not going to draw any dots around sodium. We're going to put brackets around it. So we're going to put these square brackets around it. And then whenever it gave away its electron, it became an ion. What's the charge of that ion? Positive what? Positive 1. So right outside the bracket in the upper right-hand corner, we're going to write +1. Okay? Then we're going to do the same thing for chlorine. Chlorine as an ion has how many dots? 8. So we're going to draw the chlorine with 8 dots. And then here I'm using this purple to indicate that this electron, this last dot, came from sodium. You do not have to do that, okay? So that's not a requirement. I'm just doing that so whenever we look at this, we're not like, where the heck did this dot come from? It's the dot from sodium. But whenever you write it out on your assessment or anything like that, you don't have to indicate that it's the dot from sodium by any means. You can just do it normally, okay? So then this is an ion, so what are we going to do after drawing all the dots? Put the brackets. And then what else? -1, its charge. Okay, so on your assessment, you'll have one box where you're going to draw me this, one box where you're going to draw me this. Yes? Okay. Questions about what happened here? Yes, so this is chlorine as an ion. That's a great question. This is chlorine as an ion. As an ion, it has a -1 charge, so it has 8 dots. If you only put 7 and you don't show that it gained the dot from chlorine or from sodium, then you're not going to get full points for it. And if you draw this here with sodium having that dot, again, you're not going to get full points because this is when they became ions, so that's when sodium, that's after sodium gave it away and after chlorine accepted it. Good question. Okay, anyone else? All right, so now we're going to do Li and N down here. Okay, so Li is this. How many dots will Li have? 1. Okay, and then we have N. How many dots does N have? 5. 1, 2, 3, 4, 5. Okay? So now lithium is going to want to give away its electron. So it's going to give it to nitrogen. Okay? Is this lithium happy now? Yes, because it gave it away. Is nitrogen happy? No, because how many electrons does it have now? It just has 6. How many does it, how many total is it going to want? 8. So it needs it needs to gain 3 total electrons, but right now it's only gained 1. So what do you think we're going to be able to do? Yeah, we're going to get another lithium. So whenever one of the 2 elements that we've drawn is not satisfied after we've given away electrons, we are going to add more of one of those elements. We cannot add in a sodium here because we're only using lithium and nitrogen. Okay? And are we going to want to bring in a nitrogen? No, because the nitrogen isn't giving away, the lithium is. So for nitrogen to be happy, we need to bring in another lithium. Okay? It's going to look exactly the same as the original. And so what is this lithium going to do? Give it to nitrogen. Okay? Both of our lithiums are satisfied now. Is our nitrogen? No. What do we need to do? Get one more lithium. Okay, we're going to do the same thing. Lithium is going to give away its electron to nitrogen. Okay. So then, are each of my lithiums happy? Yes. Is the nitrogen happy? Yeah, because now it's got 8. So now, we're going to draw it out using these brackets. Okay? So, ideally, what you want to do is alternate your charges, but if you don't do that, I'm not going to count off for it. Okay? So, ideally, you would want to go like positive, negative, but sometimes, like here, you can't do that. And if you don't do that when doing it on your assessment, I'm not going to count off for it as long as you have the right number of each. Okay? So, lithium as an ion is going to look like what? How many dots? 0. And then what are we going to do? Brackets, and I have a positive what charge? Positive 1. Okay. How many lithiums did we draw here? 3. So how many of these guys should we have? 3. We need to draw this guy for each lithium that we have here. So we can go ahead and just do that 3 more times, or 2 more times if you want. Nope, you got to draw each of them out. Okay, so each one of these should look exactly the same. Okay, we drew our lithiums. What else do we have to draw? The nitrogen. I'm going to do it over here so I've got more space for this guy here. How many dots is this nitrogen going to have? 8. Good. Okay. So it's got 8 dots, and then what are we going to do? Brackets. And then what else? -3 charge. Boys? Okay. All right. How do we feel about this? Okay. All right. I want you to try 3 and 4 on your own. Work with your tables. Those of you watching the video, pause it, and then come back to check your answers. All right, so this is the answer for magnesium and bromine. Magnesium needed to get down to 0, so we had to call in another bromine so that magnesium was happy and each bromine was happy. So this is what it looks like. And like I said before, the order that you write these in, I'm not going to count off for whatever order it is, as long as each bromine is correct and you've got 2 of them, and each magnesium is right, and then here you've got 1 of them. Next we had aluminum and oxygen. And this one kind of got a little tricky because whenever we did it, what did we notice? So aluminum gave 2 to oxygen, right? So now oxygen was happy, but what about aluminum? It wasn't happy, so what did we do? We brought in another oxygen. Okay, and so now aluminum was able to give away 1 to the oxygen. So this aluminum was happy. It's given away all 3. Is this oxygen happy? No. It still needs another electron. So what are we going to do? Bring in another aluminum. And so now aluminum can give 1 to this oxygen. So now is this oxygen happy? Yes. Is this aluminum? No. So what are we going to have to do? Bring in another oxygen. So what you're going to do for these guys is you're just going to keep adding whatever you need to add until everyone is happy. All of your metals have 0, all of your nonmetals have 8. So it ended up with us needing 2 aluminums and 3 oxygens. Okay, so then that's part of it. And then we have to clean it up and make it look nice and pretty with our brackets. So I'm going to start with oxygen. How many dots should this oxygen have? 8. Okay. And then what else should the oxygen have? Brackets and a -2 charge. And then you can either, if you want to do all 3 oxygens together, you can. I alternate because that's technically what we're supposed to do. But again, I said I won't count off for it if you don't. Okay, so then we've got aluminum. How many dots should aluminum have? None. So then brackets and what charge? +3. Okay, so these are the, so we've got 1 of each, and now we'll just keep adding until we have 3 oxygens and 2 aluminums. And they should all look exactly the same. Do we have questions? How are we feeling about this? Decent? Okay, awesome. So I'm going to talk about covalent, but we're not going to fully get through it, and that's okay. All right? So we're just going to talk about what the difference is, how we would draw it, and then we'll actually get around to drawing it next class. Yeah? Okay, because we'll have time next class. All right, so the difference between ionic and covalent. Ionic has a metal and a nonmetal, or a metal and a polyion. Covalent, you have just nonmetals. So in the ionic bond, we said that they, where was it? We said that they transfer electrons. What happens in the covalent bond? They share. So they share electrons so that both of them can satisfy the octet rule. So if we have 2 chlorines, we'll see that each chlorine has 7, and they each have a lonely dot. What's going to happen is they're going to get together and be like, hey, we each have 7, and we each have a single dot. If we share our single dots, we can each say that we've got 8. Because since we're sharing these 2, we can lay claim to that and say, okay, 2, 4, 6, 8, 2, 4, 6, 8. So instead of drawing arrows to give away dots and fill in empty spaces, we're going to connect our lonely dots with a line to show that they're going to share. So we're still going to start off the same by drawing the Lewis dot structure for each atom of both of our elements. And then we're going to share the electrons by connecting lonely dots. And we need to make sure that each atom satisfies, what was that rule called? Octet rule. Meaning they have how many valence electrons? 8. Now, there are some exceptions that you need to be aware of, just 3, okay? There are 3 elements that aren't going to want to have 8. Hydrogen is only going to want 2. Beryllium is only going to want 4. And boron is only going to want 6. Okay, so you need to remember that hydrogen is going to max out at 2, not 8. Beryllium will max out at 4, not 8. And boron maxes out at 6, not 8. Okay? And then if we find that we've got some extra atoms that aren't bonded together, we're going to add more lines, add more bonds, so that they're all connected together and we don't have any single lonely dots left. All right. So those of y'all who are still watching the video, I am going to finish this. So stay tuned. Alright, so let's go through and draw these. So we're going to start off just the same as we did for the ionic. We're going to draw the Lewis dot for each of these. So, hydrogen, this is H2O. So that's telling me that I have two H's. So I'm going to draw two H's. The Lewis dot structure for each H. And then I'm going to draw the Lewis dot for the oxygen atom. Okay, so now I'm going to look, and since this is covalent, I know that because it's only nonmetals. Hydrogen is a nonmetal, oxygen is a nonmetal. What we're going to do now is, instead of giving away electrons, because nonmetals don't do that, we are going to share. So we're going to connect any lonely or single dot between the atoms. So this hydrogen has one lonely dot, and it's going to connect to the oxygen. So the oxygen and this hydrogen, they're going to share these two electrons. The oxygen still has a lonely dot, and this hydrogen still has a lonely dot. So we'll connect these guys with a line. We are not drawing arrows. Arrows are for ionic. Arrows are for when we're giving away. These lines are for when they're being shared. Okay, so then now we're going to draw this again and clean it all up. So we're going to have oxygen in the middle, and it's bonded to two hydrogens. So we'll have a hydrogen kind of on each side, and wherever we had a line, we're just going to draw the line. We will not be drawing the arrows. This line is a bond, and that bond represents these two dots that we're connecting. So we do not, in our final answer that's all nice and pretty here, we are not drawing the dots that are being connected by the line. We are just drawing the line itself. Okay? So we connected, we drew the lines, but then this oxygen still had two sets of dots on there. We have to make sure that we draw that. Now, if you drew it like this, that's totally cool. If you drew it with a hydrogen going this way and one down, that's totally fine as well. Where exactly those hydrogens are doesn't matter as long as it's on one, they're each on a side. Alright? Alright, next we're going to do this, number 2. It's CBr4. So that tells me I'm going to have one carbon. My carbon has 4 valence electrons, so I'm going to draw 4 dots. And then it's telling me I have 4 bromines, so I am going to draw 4 bromines. And each bromine is going to have all of its 7 dots. Alright, so now I'm going to look and I'm going to connect any lonely dots between my bromines and my carbon. So this carbon has 4 lonely dots. Well, look, we have 4 bromines and each bromine has 1 lonely dot. So I can connect 4 bromines to this 1 carbon. And so whenever I do that and I make it look all nice and pretty, I'm going to have the 4 bromines around the carbon. Wherever I connected the dots, I'm drawing the line, not the dots that the lines are connecting, but just the lines. And then I'm going to go back and make sure I put all of the dots that were around each bromine back on. And that's your final, what we call structural diagram, or whatever it is, all nice and pretty. So just like for the ionics, how you were going to have, we're going to have one box where you draw the arrows and show me what's happening, what electrons are being given away. Same thing's going to happen here. You're going to have 2 boxes. One, you're going to show me where we're connecting these lonely dots, and then one box that's nice and final and all pretty cleaned up. So pause the video and then come back to check your answers for 3 and 4. Alright, and here are the answers for 3 and 4. So ammonia, so this is NH3, so we should have drawn one N with 5 dots and then 3 H's, each with 1. And then connect our lonely dots, and we end up with this guy. And then CO2, we should have drawn 1 carbon and 2 oxygens. The carbon has 4 dots, each oxygen has 6. And whenever we connect our lonely dots, we'll see that the oxygen is going to connect to the carbon twice. So this is what we call a double bond. This is when our atom is going to be bonded to this like central one here twice. So we'll draw 2 lines because we connected 2 lonely dots between the oxygen and the carbon. Okay, now whenever you're done, you can always double check by making sure that each element is satisfied with 8. So each bond represents 2. So this hydrogen, 2 electrons. This hydrogen, 2 electrons. Which is good because, remember, hydrogen was an exception and it only needed 2. Okay, and then this oxygen, we've got 2, 4, 6, 8, because they're sharing. So this oxygen is happy. Do the same thing down here. Carbon, each bond is 4, each bond is 2, so 2, 4, 6, 8. This carbon is happy. Each bromine has 1 bond, that's 2, and then 3 pairs, so 2, 4, 6, 8 for each one. Each one of those is happy. Nitrogen has 3 bonds, so 2, 4, 6. This pair here makes 8, and each hydrogen only has 2, so it's good. Carbon, it has 4 bonds, just 2 doubles, so 2, 4, 6, 8. This carbon is happy. Oxygen has 2, 4, and then 6, 8. Oxygen, 2, 4, 6, 8. So each of these guys is happy, and at the end you do want to double check and make sure that each of these atoms that you drew is satisfied with the amount that it wants. Alright, so next class we're going to be talking about what it looks like whenever we have things called diatomic elements. And then we're going to talk about the shapes that these guys make and what their name is. So, if you have a question, please come see one of us for tutorials. Otherwise, happy studying, and I hope you have a great rest of your day.